In this video, we're going to cover section 6.6, which is going to be on the law of cosines. This is going to be another technique that we're going to be able to use when we're working with these oblique triangles. And remember, an oblique triangle is going to be a triangle that has an obtuse angle. So some angle between 9 or above 90, but less than 180. And another way to think about this is a formula that's good for triangles that are not right triangles. And so in this little diagram that we have here, we actually have an oblique triangle. Okay? And with this oblique triangle, it has three side lengths, A, B, and C. And in addition to that, there are two right triangles within this oblique triangle. And it's going to be the right triangles that we're going to use to help us come up with our formula. Or actually, we'll have a set of three formulas here. And so, is what I'd like us to do is start off by just thinking about cosine of b. All right. Now, there's only one right triangle that contains side length b here. Okay. And that is this one that I've kind of shaded here. Okay. And so, if we try to find cosine of b, cosine should be adjacent over hypotenuse. Okay. Well, the adjacent side isn't so clear. It's this one here. Well, you can see that the base of the big oblique triangle is C, and that the base of this other right triangle is X. So is what this distance here must be, the base of the right triangle that we're interested in, it should be C minus X. Okay. And I'm calling this the base here, but in terms of cosine, right, this is our adjacent side. Okay. So adjacent is C minus X. Okay. Next, I want to divide that by the hypotenuse, which is of length little a. There we go. So is what I'm going to do is I'm going to solve this equation for X. Okay. Then we're going to make another equation and we'll solve it for Y. Okay. So let's start off with solving this one here for X. So I'm going to multiply each side of the equation by A. So little a cosine big B is equal to little c minus X. And then if I want to finish solving for X, I could add X to each side and then subtract by a cosine B on each side. And that's going to leave us with X is equal to C minus a cosine of big B. There we go. So there's one equation that we're going to use. Let's see if we can come up with another one here. So this time I'm going to look at sine of B. So sine should be opposite over hypotenuse. And so our opposite side is y. Our hypotenuse is a. So it's just y over a. And so this one's going to be a lot easier to solve for y. We just need to multiply each side of the equation by a. And so we get y equals a sine of b. Okay. And specifically, that's little a in big B or capital B. All right. So now we have those two equations. And I want us to now focus in on the other triangle. Okay. This one here on the left, the other right triangle. Okay. Well, I could actually apply my Pythagorean theorem using these three values here. And so I'm going to do that. So I'm going to say, well, b squared is equal to x squared plus y squared. Okay. And from here, I can actually go and I can replace the x here with, what was it? C minus a cosine b. And I can replace the y with a sine b. So I'm going to do just that. This gives us b squared is equal to c minus a cosine of big B squared, then plus y squared, and y is a sine of big B. And so I'm going to have us FOIL this out, and we'll eventually then factor a part of it and do some simplification. And we'll get one of the three formulas that makes up the law of cosines. So we're getting close. Okay. So let's go ahead here and we're going to distribute. So I need to FOIL. So c squared minus 2ac cosine of big B, then plus a squared cosine squared of B. And then now we're finally onto this last one. So if you square this, we get an a squared and a sine squared of B. There we go. And so it's going to actually be these two things where the simplification is going to occur. I can actually factor an a squared out of those. And one thing you might remember here is something called the Pythagorean identity, which says that cosine squared of b plus sine squared of b is equal to 1. So that means I can rewrite what I have here as just simply b squared is equal to, and let me fix my arrow here. There we go. B squared equals c squared minus 2ac cosine of big B plus a squared. Okay. And the only thing I would change here is that this is usually written in this form. So we have b squared equals a squared plus c squared. So I'm just moving this a squared towards the front. Okay. Minus 2ac cosine of b. Okay. And so I'm choosing to write it in that order because I'm going to write actually all three of the formulas kind of in this format here. Okay. So let's go ahead and actually write in here that we're going to write down our law of sines now. This is one of the three formulas. All right. So the first one, um, and actually, I'm going to write in the second one first because we already have it. But is what I kind of want you to notice um, is the way this works is you have side length B here and angle B here. So whatever angle you're using, the corresponding side is going to be on the other side of your equation here. Then the a squared plus c squared, these are just the other two sides of this triangle. And you'll use those two sides again here. And so I'm trying to point this out because now I'm going to go a squared equals the other two sides squared and added together minus 2 times those two sides. And then times cosine, which I'm going to try to write that cosine a little bigger so that this is clear. And then the angle should be the angle opposite of this side. So that's going to be big A. And then lastly, c squared is going to be equal to the other two sides squared and added together minus 2 times those two sides. And then lastly, times cosine of the angle opposite of the side C, which is big C. Okay. So we only derived this one, but you could go through and do a very similar process to derive these other two. Okay. So these will be our three formulas here. And again, if you can remember one, the other two follow kind of the same format, so it's easy to remember. I've added a little note up here. So you might remember that with our law of sines, it didn't work very well for finding obtuse angles. We always had to do 180 minus sine inverse to get the obtuse angle we were looking for. Well, cosine inverse doesn't have that problem. Cosine inverse can actually give us angles from 0 to 180 instead of minus 90 to 90. So cosine inverse is really good, or maybe I should say law of cosines is better for finding obtuse angles than the law of sines is, because you don't have to accommodate for the fact that your inverse trig function maybe won't give you the angle you're looking for. Now, sometimes we don't have a choice and we have to use law of sines maybe to find that obtuse angle. But if you can avoid it, use law of cosines for the obtuse angles. Okay, so let's go ahead and give one a try here. So it looks like we have two sides and the angle in between them. So this is sometimes called side angle side, and this is a common type of question that we'll solve using the law of cosines. And specifically right now, I'm going to try to find this side. And that formula, when I am maybe trying to solve for, say, b, it might be best to start off with the formula that starts off with maybe b squared. So b squared is equal to a squared plus c squared minus 2ac, and then cosine of big B. So then I have b squared is equal to, and now I'll fill some of these things in. Although I think I'm going to scoot this over just a little bit. And let me bring this down. There we go. All right, so our A, that looks like it is, so opposite of angle A is side A, which is a 6. So I have 6 squared. Looks like C must be that 8 squared. And then minus 2 times A, which is 6, times C, which is 8. And then cosine of the angle B, which is 32. And I do want to point out we could not have used law of sines here because we don't have a matching pair. And is what I mean by matching pair is for the one angle we don't know its corresponding side. And for the two sides that we don't know their corresponding angles. Okay. So law of sines would not have worked here, at least in the beginning. Maybe if we find another side or angle, that'll change. Yeah. So if we keep going here, we really just need to plug this into our calculator and then take the square root of that. Okay. So I'm going to go ahead and scoot this over and we'll get this plugged into the calculator. So we have our 6 squared plus 8 squared minus 2 times 6 times 8 times cosine of 32. Okay. And this is equal to b squared. So after I hit enter, I'm going to want to take the square root. But I should also double check that my calculator is in degrees, and I see mine is. So now I should be able to hit enter. So it's b squared. And to get b, again, I just need to take the square root of this. Okay. And so we're getting about 4.3 here. Now, this is b. I'm going to store this on my calculator. I would store it as lowercase b if I could, but I can't. So I'm going to just hit STO here, and then alpha, and then the letter B. Okay. Let's go record this over here. Okay. And I just want to note that I did store this in my calculator. There we go. All right, so now that we have B, we still have two more missing things, the angle A and the angle C. Okay. Now, I am in that situation that I was talking about now where it looks like I may have an obtuse angle here. Um, and I also have another angle over here that looks like an acute angle. So it would be best if I want to use, say, law of sines, because law of sines is easier to use than law of cosines. Um, Maybe I'll use it to find this acute angle, okay, instead of that obtuse one. So let's go ahead and do that. Okay. I'm going to use law of sines. Okay. So sometimes you're going to use both of these laws, law of sines and law of cosines, in one question. Okay. So um, since we do have now a matching pair here, we can maybe go through and find again this missing angle. Ooh, that didn't do what I wanted it to do. We can find this missing angle here. So I'm going to write sine of A divided by 6. And then we have our matching pair over here, sine of 32 over B. And rather than writing down the decimal approximation for B, I'm just going to be specific here and just say B. Okay. And our goal here again is to solve for big A. So I want to multiply both sides by 6 and then take sine inverse of each side. So if I do that, that's going to give us A is equal to sine inverse of 6 times sine of 32 all over B. Okay. So let's go ahead and find that angle A now in our calculator. So I'm going to have sine inverse of 6 times sine of 32. And then I want to divide that by B. And remember, I stored that as actually capital B in the calculator. So I'm getting about 47.5 here. Or if I were to round that to the nearest degree, that would be about 48 degrees. And so all that we have left then is to find the angle C, which should just be 180 minus the two angles that we already know. So we know the angle A, and we know the angle that is 32 degrees. Okay. So I already have A in my calculator. It's this 47.5 something. So I'll just do 180 minus my previous answer minus 32. And if I round that to the nearest degree, that's going to be about 100 degrees. Okay. It just barely rounds down to 100 there. All right, and so we have actually finished solving this triangle. All right, and so if you're feeling up for it, you can go ahead and pause the video here and see if you can do part B. Otherwise, I'm going to start this here in just a moment. So I want us to note we have a different layout here. Before we had an angle that was in between two sides. And to be specific, I mean, we knew an angle that was in between two sides that we knew. Okay. Versus this time, we don't know any angles, but we know all three of the sides. So we're going to actually have to find here angle A, angle B, and angle C. Now, when I do go to use my law of cosines here now, I could actually use it to find A, B, or C. It's really actually up to me. But I want you to see that there is an obtuse angle here. And so if it were me, I would prefer to find this obtuse angle using my law of cosines, because then I don't have to make any adjustments that I might have to with the law of sines. So I'm going to find angle B now, and I think I'm just going to use my law of cosines. And again, you can't use law of sines here because we don't have a matching angle and side. There's not a side that we know its corresponding angle as well. So let's get started here. We're going to work with angle B. Then we should take little b, which is 16, and square it. And then we should take those other two sides and we should square them and add them together. Minus 2 times those two side lengths that we just wrote down. And then cosine of the angle in between those really two sides. Okay. So that's going to be, again, angle B. Okay. All right. So we want to start solving for B. It might be a good idea to maybe let's move this stuff over. Let's add that stuff to the left-hand side. So we'll have 2 times 8 times 10. Or if we really want to compute that, right, 2 times 8 is 16 times 10, that's 160. So I'll have a 160 cosine of B over here on the left. And on the right here, I want to do that 8 squared plus 10 squared and then subtract 16 squared. 8 squared plus 10 squared minus 16 squared. And so, yeah, there we go. That gives us minus 92. And make sure we have that right. Uh, yeah, minus 92. And again, that's from doing 8 squared plus 10 squared minus 16 squared. So we're almost there. We just need to divide each side by 160. And let's just see if that simplifies to, anything nice. Okay. So again, minus 92 divided by 160. And just checking to see if that simplifies nicely here. It does, minus 23 over 40. And then lastly, we just need to take cosine inverse of each side and we will have B. There we go. So let's go type that in, cosine inverse of minus 23 over 40. All right, so that's giving us here about 125 degrees. I'm going to store that as B, just in case I want to use this angle again at some point. So I'm going to say, again, about 125 degrees. And we're just going to round all these to the nearest degree. All right. Now, I could use law of cosines again to find angle A or angle C. Okay. But you can see it does take a little bit more work again to use law of cosines. So I'm going to have us switch over to law of sines. And this time, let's find, let's say, A. Okay. So if we're going to find angle A, I'm going to say sine of big A divided by the side opposite of it, or the length of the side opposite of it. And then I'm going to say that that's equal to sine of B, which I already have stored in my calculator. And then I want to divide that by the side length opposite of the angle B, which is 16. Okay. So again, we're trying to solve for A. So you're going to want to multiply both sides by 10 and then take sine inverse of each side. I'll give a sine inverse is equal to 10 sine of B and then all over 16. All right, so let's go ahead and get that one plugged in. So I have sine inverse 10 sine alpha B, and then I want to I wanted to divide that by 16 before I close off my inverse sine here. So that looks like that matches perfectly. Let's hit enter. So if we round this to the nearest degree, this is going to be about 31 degrees, but I'm going to store it as A. There we go. So yeah, about 31. Then all we have left to do is find the angle C. And we know that if we just do 180 minus these two angles, we should get that angle C. So we will do that right now. So C should be equal to 180 minus A and minus B. And let's go see what that gives us. And we have A and B already stored on our calculator. So that's giving us about 24 degrees. Again, if we round that to the nearest degree. There we go. All right. And I have one more question I'd like us to do here. So if we come down here, we have an application question. It sounds like we have two airplanes. And so it says plane A leaves airport A and travels 540 miles to airport B on a bearing of north 34 east. So let's just start off with that. I'm going to have a sketch what that sentence says. Okay, so for one, I'm actually going to sketch in here a north-south line. And this has to do with the fact that we were given a bearing angle here. So here's kind of my north line, or maybe I should say north-south line. Okay. And so I'm going to just label this up here as north. Okay. And I'm going to make another dotted line here and arrow off and call this the east. Okay. And so when you see something that says north 34 degrees east, is what that really means is that you want to start off. This is how you want to visualize this angle. Is you want to imagine starting off here, and actually I'm going to use a different color. Okay. Let me switch this. So you imagine starting off on the north line, and you want to rotate 34 degrees towards the east. That's what that means. Okay. I'm going to make this a little bit bigger here. There we go. There we go. I was just trying to get that to line up nicely there. And I don't really want the arrow here with this because I'm gonna make it into a triangle. So I'm gonna resketch that line one more time here. Let's do that. So again, starting off on the north line, just rotate 34 degrees. I'm gonna call that about 34 right there. All right, and so I'm going to call this airport A right here. And I'm going to call this up here airport B. There we go. Okay. And it was said that the distance between these two is 540 miles. Actually, I'm going to just go like this 540 miles. And I'm going to just turn this. There we go. Okay, so we got that labeled. Okay. So after they got to airport B, it says the plane travels to airport C, 410 miles away on a bearing south 71 degrees east. Okay. So I need to draw in actually another north-south line here. But this time, since we're headed south, I'm just going to draw in a south line. And I'm going to draw in an east line again, right? It says we're headed southeast. Okay. And so the way you want to think about this one is we're going to make another line, but we're going to start on the south line because it's south 71 east. Okay. So starting on the south line. And I want to rotate 71 degrees towards the east. Okay. So that's probably going to leave me somewhere up here. And I only want to go 410 miles this time. So to make my picture have some accuracy here, I'm going to try to make this one a little bit shorter here. Maybe I'll go right in here. There we go. And so we have now landed at Airport C here. Okay, there we go. Now, let's fill in some of these angles, right? So I want to remind us again, we went 34 degrees from the north line towards the east. And for our other bearing that we were given, we went 71 degrees from the south line um, towards the east. Okay. So we know those two angles. Okay. And we actually know another angle here that's not quite as clear. Okay. So this angle right here and this angle here are what we call alternate interior angles. Okay. If I were to actually maybe resketch this in a slightly different way, it might be a little more clear. I'm going to make it look like how it looked when you probably took geometry, probably quite a few number of years ago. And let's see. So, is what I'm trying to get at is if this one's 34 degrees, is what that tells us is that this one right here is also 34 degrees. These again are what we call alternate interior angles. And let me just kind of write that up here. Okay. So, is what that means is I'm going to put a little 34 right here as well. So, this total angle here is going to be 34 plus 71. Okay. We'll want to keep that in mind at some point. And maybe I'll actually just write it in now. So if you were to add those two up, um, we should get 105 degrees. Okay. And our goal here in the end is to find the distance between airport A and airport C. So I'm going to go ahead and connect those. And so, yeah, this is what we're looking for right here. This dotted line I'm putting in the orange on top of side length AC. That's the length we're looking for. And let's maybe give that a name. Let's just call it little b. All right. There is one more thing I realized I'm missing from my diagram, and that this side right here is 410 miles. Okay. So to find this side length b here, is what we'll do is we'll use our law of cosines. So if I'm trying to find b, I have b squared equals the other two sides squared and added together. There we go. And then minus 2 times both of those side lengths. And then cosine of the angle in between them, which is that 105. And so all we need to do is plug this into the calculator and then square root it, and we will have b. Let's scoot this over. So we have 540 squared plus 410 squared minus 2 times 540 times 410 cosine of, and again, the angle is 105. Okay. And then you don't want to forget to square root it. There we go. And so I'm getting about 757.8 miles if I round this to the nearest tenth. So let's go record that. All right. And so this wraps up. I think this is all we wanted. Yeah, this wraps up 6.6.